Hello everyone, welcome to Anand's YouTube channel. Today we are going to learn about soil-water relationship. Okay, so this is a topic related to soil mechanics, and it is very important to study this topic if you are beginning to study the soil mechanics. And after that, we will study the foundation engineering also. So let's begin. So before we start the relationship, we should know certain terms like void ratio, water content, degree of saturation, unit weight of water, specific gravity of solids. Okay, so to develop the relationship, we are going to use three-phase system in which at the top there will be air, and in middle there will be water, and at the bottom there will be soil solid. Air and water are known as voids present in the soil. So uh, Va means air voids, okay, and what does VW means? Water voids, okay, and Vs means soil voids related to soil. So void ratio is simply ratio of voids upon void of solid. Okay, so void will constitute of air and water, and then water content small w is given as weight of water divided by weight of solid. Okay, so on the left side we have written volume parts, and on the right side we have written weight part. Okay, so let's begin to develop the relationship. Okay, so as water content is equal to small w is equal to weight of water upon weight of solid, so we will write weight of water as water content multiplied by weight of solid. So total weight, capital W, can be written as weight of water plus weight of solid, so we can replace weight of water by w into ws. Taking ws as common, we will get weight of solid as capital W upon 1 plus small w. Okay, so this is the first relation we are getting. The second relation we will get using the definition of void ratio. So as void ratio is defined as volume of voids upon volume of solids, so we can write volume of void as E multiplied by Vs. So total volume will be Vv plus Vs. We can replace Vv by E into Vs, and taking Vs as common, we can establish the relation as Vs equal to total volume divided by 1 plus void ratio. Okay, let us go to the third relation. So to define the third relation, or to establish the third relation, we will use the definition of porosity. Porosity defined as volume of void divided by total volume of this three-phase system. So as we already know, volume of voids can be written as E into Vs, and total volume can be written as volume of voids plus volume of solid. So putting the value of volume of voids in the numerator and denominator, and taking Vs as common and cancelling it, we will get the relation n is equal to E upon 1 plus E. From here we can also establish one relation as, since if we cross multiply, we will get n plus ne is equal to E, or we will get n is equal to uh, E1 minus n, or E is equal to can be written as n upon 1 minus n. So you should also remember this, that n is equal to E upon 1 plus E, but void ratio E is equal to n upon 1 minus n. Okay. To get the fourth relation, we will use the definition of degree of saturation. Degree of saturation is denoted by capital S, and it is given as volume of water divided by volume of voids. So what we will do uh, to derive the relation, we will start with E as Vv by Vs. Now cross multiply means multiply numerator and denominator by volume of water, and take the volume of void in the first term. In the denominator, you will get volume of water upon volume of void. Now volume of water upon volume of void can be replaced by S. Okay, and volume of water on the second term can be replaced by weight of water upon unit weight of water. Similarly, we can replace volume of solid as weight of soil solid divided by unit weight of soil solid. So using all this definition, if you simplify, you will get E as 1 by S WW by WS into gamma S by gamma W. Gamma S upon gamma W is nothing but specific gravity of solid, and weight of water upon weight of solid is nothing but uh, water content. Now cross multiply, you will get a very important relation, ES is equal to W gamma GS. Okay, so E is nothing but here void ratio. What is S? S is nothing but degree of saturation. What is small w? Small w is nothing but water content. And what is GS? GS is nothing but specific gravity of soil solids. Okay, so it is a very important relation because in this relation we are getting relation between four different terms. Okay, let's go to next relation. Now to define this relation, we will again use a different three-phase diagram. If we assume volume of solid as 1, then using P as VB by Bs, we can write volume of void as E into S, and since S is 1, volume of void is equal to E. Now S is equal to volume of water upon volume of voids. So volume of water can be replaced as S into volume of void. Now volume of void is E, so volume of water can be written as S into E. That's what I have written here. Okay. Now since if you know the volume of water, you can find the weight of water by multiplying volume of water with gamma W. Now, so volume of water is Se, so it will be C gamma W. That's what I have written here. And if you know the weight of water, you can find the what this volume of weight of solid. Okay, since volume of solid is 1 and gamma S is equal to weight of solid upon weight of volume of solid, so Ws will be equal to gamma S, and since Gs is equal to gamma S by gamma W, you can replace Gs as gamma S as Gs into gamma W. So that's what I have written here, Gs gamma W. Now to find the bulk unit weight, you have to divide total weight by total volume. Now total weight here is sum of these two terms, and total volume is 1 plus E. So if you add and take common, you will get final relation as Es plus Gs into gamma W upon 1 plus. See, using the previous relation, we can change this relation also, since we can write Gs gamma W in the place of Es, and Gs gamma W upon 1 plus C. Okay, W, Gs W. If we take Gs common, so you will get relation 1 plus W upon Gs gamma W upon 1 plus C. That's one more relation you can write for bulk unit weight. Okay, so let's move to sixth equation. For sixth equation, simply to find the saturated unit weight, you put the value of S as 1. Saturated soil will become saturated only when S value is 1 or 100%. So just write the value of S as 1, you will get the common set as E plus Gs into gamma W upon 1 plus E. And to find the dry unit weight, you have to simply put saturation as 0. Okay, so put the value of S0, you will get gamma ds, Gs gamma W upon 1 plus E. And there is one more unit weight which is called as submerged unit weight. Submerged unit weight is denoted by gamma dash. Gamma dash is defined as gamma set minus gamma W, and we already know gamma set value. If you put it and simplify, you will get gamma dash as Gs minus 1 into gamma W upon 1 plus E. Okay. To get the next relation, we will use the definition of percentage of air void. Since Na is equal to Va upon V, we can write 1 minus Na as 1 minus Va by V. Then we write V minus Va upon V. Then total volume is equal to volume of air plus volume of water plus volume of solid. Okay. So if we write V minus Va, that means we can replace it by volume of water plus volume of solid. And volume of water and volume of solid, as I already told, can be replaced in weight and unit weight term also. So if you put and take the terms in denominator, you will get this equation. And using the definition of water content and dry unit weight, you can replace or you can change the relation further, and you will get final relation as 1 minus Na is equal to the small w into gamma d upon gamma w plus gamma d upon gs into gamma w. Taking gamma d upon gamma w common and rearranging the term, you will get gamma d as 1 minus Na gs gamma w upon 1 plus wgs. Okay, and last relation can be defined by using the definition of degree of saturation, and try to understand this new phase diagram. Okay, as I already told, if you take volume of solid as 1, then volume of void will become E, then volume of water will become Es, then weight of water can be found by Es gamma W, replacing Es by Gs gamma W, and then weight of water content is weight of water upon weight of solid. Weight of solid can be found dividing this term by w, small w. So small w will get cut, we will get gs gamma w. And since this 2 represent the total weight, if you divide it by the bulk unit weight, you will get the total volume. That's what I have written here. So from the above diagram, it is clear that gamma T can be written as weight upon volume, WW upon WW plus WS upon V, and replacing it by water content, taking water weight of solid as common, and we will find a new relation here that gamma D is equal to gamma T upon 1 plus W. So this is the relation between dry unit weight and total unit weight. Okay. To get the relation for say degree of saturation, we will start with S is equal to water volume of water upon volume of solid, replacing volume of water by WW upon gamma W, and then replacing further weight of water with the help of water content, and replacing weight of solid with Gs gamma W, and to replacing total weight by WW plus WS, and solving it and taking the Gs in the denominator, we will get the relation of S is equal to small w upon in the denominator first term will be gamma w into 1 plus w upon gamma t minus 1 upon gs. So this is also very important relation. So these are all the important soil water relationships that we should study before starting the soil mechanics. Okay. So thank you for watching this video and have a nice day.